Hey guys, this is Mrs. Harbin, and this is Algebra 2. Today we're looking at section 5.6, all about solving quadratic equations by completing this square. And remember, when we talk about solving quadratic equations, what we're trying to do is find the value of x. We still haven't really worked on graphing them yet, but those x's will be really important when we do get to the graphing component. Our life application for our unit is this: the student will realize that he is a unique person, wonderfully made by God with a unique place in Christ's body. We've been talking about how in math and in other parts of creation, we see that God has created these individual components to work together in unity and unison. And we've talked about how that's true in the church and how that's true in math and how it's true in all of our subject areas, but it's also true of you, that you are an important component or an important part in what God has tasked us to do here on this earth. Our lesson objective today is that you, the student, will solve quadratic equations using completing the square. So we've talked about factoring, and we've talked about multiplying polynomials, and we've talked about solving by factoring and solving by taking roots. But what about when you can't factor and you can't take roots? Well, that's where completing the square is going to come in handy. Many real-life applications of quadratic equations can't be solved by plain old factoring or taking roots, and so we've got to do some other things. So remember back to those perfect square trinomials. We looked at those first in our very first section on factoring, and we recognized these patterns. That a squared plus 2ab plus b squared, if we were to factor that, would always be this a plus b squared. And if we're given a plus b squared and we're asked to multiply it, we know when we multiply it out, we're going to get a squared plus 2ab plus b squared. That was our square of a sum. The other perfect square trinomial we got was from the square of a difference. A minus b squared always produces this a squared minus 2ab plus b squared. Or if we're having to factor this perfect square trinomial, and we notice there's a difference here, we can take a shortcut and end up with a minus b squared. So we are going to refer back to that today when we talk about completing the square and these perfect square trinomials. So let's take a look at x squared minus 8x plus 16 equals 49. Hopefully the first thing that we notice is that our first term and our last term are both perfect squares. This is x squared and this is 4 squared. When we look at the middle term, we should also notice that this middle term is 2 times the square root of this and the coefficient of this, or the square root of this. 2 times 4 times x, 8x. So we should notice that pattern right away and refer back to that perfect square trinomial. Because of that, we can take this left side of the equation and we can rewrite it using that x squared minus 2ab plus b squared. We're going to write x squared minus 2ab, remember our b is the square root of this number, plus b squared equals 49. We can then kind of go in reverse order here and go back to that square of a difference. And we know that if we were to factor this, we would get x minus 4 squared. We know that it's minus because we have a minus 2ab right there. Once we have x minus 4 squared equals 49, then we can take the root of each side. So we get x minus 4 equals plus or minus 7, and from there we can solve for x. We would know that x is either 4 plus 7 or 4 minus 7, so our two values of x are either 11 and negative 3. Again, this is all going back to those perfect square trinomials, where we're using a square of a difference or a square of a sum. So that's great when we're working with, quadratics or equations that already have perfect squares. But what about when they don't have perfect squares? Well, I've got some good news for you. Every quadratic equation can be changed into an equation in which one side is a perfect square trinomial, using a process called completing the square. Every single equation can be changed into that perfect square trinomial, which means that we can use what we already know about square of a difference and square of a sum to solve for x. Let's take a look at what this looks like. To complete this square of an expression in the form x squared plus bx, add the square of half the coefficient of the linear term. The linear term is the term where x is being raised to the first power. The coefficient would be this b term. So if we take half of that coefficient and square it, that's called completing the square. It would look like this. X squared plus bx, and then we would take half of the coefficient term and square it. Well, now we have a perfect square trinomial. And depending on this symbol that's in front of the b, we could use the square of a difference or the square of a sum to factor it. Here we've got the square of a sum. The sign of b can be ignored when b over 2 is squared because the result is always positive. The sign of b is going to help us know whether it's a square of a difference or the square of a sum, but when we're completing a square, that sign doesn't matter. Remember that if you add a number to one side of an equation, however, you must add the same number to the other side. So let's put these steps in action. Let's take a look at how we would complete this equation using completing the square, solving for x. So the first thing we want our x squared term and our x term on one side, and our constant term on the other side. This one's already done for you with the 15 on one side. Then we're going to complete this square. We're going to take half of our b term, in this case, half of our b term, 10 over 2 is 5, and we're going to square it. So I'm going to add a 5 squared here, and whatever I add to one side, I have to add to the other. We've got 5 squared here, 25. We can leave it as 5 squared, or you can go ahead and write 25. I personally prefer to leave it in the 5 squared term because of what we're going to do next. Okay, and then 25 on the other side. Then we're going to use this square of sums rule. We're going to recognize, oh, this is a perfect square, and this is a perfect square, and this is just 2 times AB, so I can use that square of sums to factor and write x plus 5 squared. Okay, this kind of goes back to why I like to leave it as 5 squared, because if I square it and get 25, then I have to do another mental step and go, now wait, what's the square root of 25? So I can just bypass this 25 and just leave it as 5 squared. And that will become my sum of squares. On the right-hand side, I combine my 15 and 25 to get 40. Now I have something that I can solve by taking the square root. So I'm going to take the square root of both sides. That gives me x plus 5 equals plus or minus square root of 40. Then I'm going to use everything that I learned in the previous lesson to simplify this radical. Using prime factorization, I get 2 times the square root of 10. Now I'm going to isolate the x, and when I do so, I get x equals negative 5 plus or minus 2 times the square root of 10. If I need to get decimal approximations for those two values, I can plug those into my calculator. Negative 5 plus 2 times the square root of 10 and negative 5 minus 2 times the square root of 10. And that will give me these two approximations. X is approximately 1.32 or negative 11.32. So let's take a look at this step-by-step process now. I've talked you through it, but let's see it in writing while we complete these steps for completing this square. First, we're going to write the equation in the form x squared plus bx equals c. So we want our constant on one side, and we want our x squared, our quadratic term, and our linear term on the other side. We'll complete the square by adding b divided by 2 squared to both sides of the equation. After we've done that, we'll factor the perfect square trinomial using square of a sum or square of a difference, and then finally solve by taking roots. So let's see these steps side by side with an actual problem. So step 1, let's write the form x squared plus bx equals c. Here is my quadratic term, here's my linear term. I need to move my constant term, and I'm going to do that by adding 56 to both sides. Step 2, my x squared, or my quadratic coefficient, must be 1. Right now it's 7. So I've got to divide everything by 7, and that simplifies my equation to b squared minus 2b equals 56. Step 3, so I've done 1 and 2. Step 3, add b divided by 2 squared to both sides. So I'm going to take my b, divide it by 2, and square it, Well, 2 divided by 2 is just 1 squared. So 1 squared, and I'm going to add that to both sides. In this case, 1 squared is just 1. We got b squared minus 2b plus 1 equals 9. Now I'm going to factor it. Okay, I've got a subtraction sign here, so I'm going to use these, that square of a difference, which is a minus b squared. So I've got this minus this squared, b minus 1 squared, equals 9. And now I can solve by taking roots. Taking the root of each side, I get b minus 1 equals plus or minus 3. Isolating and solving for b, I get b equals, have one of both sides, 1 plus 3, which is 4, or 1 minus 3, which is negative 2. So my two possible values are negative 2 and 4. All right, let's try another one. Step by step here. First, let's write the form x squared plus bx equals c. I've got to get my constant on the other side, so we're going to add 10 to both sides. My x squared coefficient must be 1, so I've got to divide everything by 3, which leaves me with x squared minus 13 over 3x equals 10 over 3. Now let's complete the square. Add b divided by 2 square to both sides. Now, in this case, 13 over 3 divided by 2 is going to leave me in this fraction. So it's really going to be better to not multiply out that completed square term. A 13 over 3 divided by 2, which is the same as 1/2, gives me 13 over 6 squared. I'm going to leave that 13 over 6 squared term here. I'm not going to multiply it out. When I add to one side, I need to add to the other. Then I'm going to go ahead and factor. Using that square of a difference, I get my x term here and my 13 over 6 term here, and all of that is squared. And on the right-hand side, I've got to simplify this lovely set of fractions by changing the denominator, and then I can add. I get 289 over 36. And then we'll solve for x by taking the root. Okay, the square root of the left side is just x minus 13 over 6. And the square root of the right side, we get square root of 289, which is 17, and the square root of 36, which is 6. So our answer is plus or minus 6, but we still haven't solved for x. Adding 13/6 to both sides, I get x equals 30 over 6, or negative 4/6. We can simplify that even further. I get x equals 5, or x equals negative 2/3. All right, today we solved quadratic equations using completing the square. We had to rely on our previous knowledge of perfect square trinomials and those patterns of square of a sum and square of a difference in order to complete that square. We learned that every quadratic equation can be solved by completing the square. So, if you guys have any questions, be sure to write those down, and we will make sure we get those next class.